Hello, everyone. My name is Ziad Azrai. I'm a software engineering manager at Actian in the Zen Edge Data Management Group. And today I'd like to talk to you about using Zen in Docker containers and Kubernetes for multi-access edge computing and IoT. For those of you who don't know us, we're the product of several mergers and acquisitions. Not going to read all of this to you given our time constraints, but we are profitable, stable, and most importantly, innovative. Not over a short period of time, but over decades, we've continued to evolve and adapt. We adopt new standards and technologies with relative ease. We know data well and what it takes to support mission-critical deployments. Data management is our focus today, with an industry-leading and high-performance hybrid cloud data warehouse through our Avalanche platform, enterprise data integration, and our Edge and NoSQL solutions, all backed by over 50 patents. We are in 24 of the Fortune 100, with over 3,000 global companies supporting them 24/7, with customers and partners across many sectors from retail, finance, manufacturing, healthcare, energy, government, and education. As for the product I'm demoing for you today, Zen is a purpose-built data management solution for the edge. With 0 DBA, as in no database admin required, nano footprint for small embeddable library for your iOS or Android application, to gateway-sized installs and deployments, to even enterprise heavy workload deployments, with both NoSQL key value access APIs and ANSI SQL-based APIs, all sitting atop a common format of data, giving you the speedy access to your data with NoSQL and the flexibility and reporting capabilities of SQL. Zen is capable of supporting the diversity of the edge, from varying data such as JSON, video, images, and audio, to different operating systems such as Windows, Linux, and Mac, and mobile operating systems as in iOS and Android, and even Raspbian, and architectures. We run on Intel x86-based architectures and ARM, all running on the same engine, no matter the deployment methodology, and all sharing the same common data format, removing the need for ETL when data moves throughout the edge, and maintaining the same standards of security and encryption throughout your solutions. And all this doesn't come with a compromise in performance. When benchmarked by a third party against other data solutions, we were 38 times faster than InfluxDB with time series data, and JSON blob data and document store data. We were 3 times faster than Couchbase and 6 times faster than MongoDB. I could talk all day about how amazing Zen is and all its features, but I'll spare you. Just know that when it comes to edge data, we have you covered. So let's take a quick look at 2 of the driving forces behind the growth in data processing at the edge and the network edge and multi-access computing. First being latency. When you have latency sensitive applications at the edge, moving data processing to the cloud could lead to usability and accuracy issues. If you take, for instance, if latency goes above 5 milliseconds, you will start to see disruptions in automated driving, IoT, and in gaming. Latency above 10 milliseconds will disrupt augmented reality and medical applications, and latency above 30 will disrupt video analytics. The second force being bandwidth and data volume, where wholesale moving of data to cloud warehousing becomes slow and costly. New edge devices are coming online at an astonishingly fast rate, and moving all the data they generate is fast becoming inefficient. With that said, MEC isn't meant to compete with or replace cloud computing. It is meant to complement it, allowing data processing to happen at the appropriate depth in an IoT solution will allow for better resource utilization and better customer experience. But why containers for MEC and IoT? Well, as we saw earlier, data processing can shift left with latency, bandwidth, and data volume when they become factors for an IoT solution. As this shift happens, pre-existing solutions in the cloud don't need to be abandoned. They can simply shift left as well if the environment in the MECs and the edge support them. In fact, that is one of the strengths of cloud native development, the agility in development and deployment. And this is already recognized by industry leaders as the natural next step to complementing the cloud with edge intelligence. Leaders like Intel with their Smart Edge platform, formerly known as OpenNS. It is a CNCF certified Kubernetes cluster, and Zen is certified to run on it. Also, at the physical edge with solutions from Microsoft with Azure IoT Hub and Azure IoT Edge, and Amazon with IoT Greengrass. So let's move to the demo. I'm going to be showing you, I guess, 3 things today. First, we will build a Docker container together, build up a Docker file, and then we're going to deploy the container and a sample application you built for Zen using Docker Compose, and we'll do it again, deploying the container and the sample application as a pod using Helm in a Kubernetes cluster. So let me go ahead and share my demo environment. Here we go. Okay, we'll start off by building the container together. In this environment, I've already downloaded a copy of Zen Enterprise Linux x86, and we are going to start to build the Docker file together. So let us start. Before I begin that, actually, just to show you, there is, as far as images go, the only image we have on this host is Ubuntu, the 2004, which is the LTS release, and nothing really else. Is a plain vanilla Docker install. We're gonna build everything up together. Oh, sorry, don't even need to do sudo on this one. Okay, so let's start. First thing we need to do is choose our base image, and we are, like I showed you, gonna go with Ubuntu 2004. The next thing we need to do is expose some ports. The Zen service utilizes 2 ports, 1583, which is the port for SQL operation, and 3351, which is the port for our btrieve, the NoSQL APIs. And next, we just need to copy over the install to the container, and I need to copy it over. I forget, there it is. And we typically install Zen in user local. So once that is copied and extracted, we will want to run the installer, which will be under that folder, user local Actian Zen, etc. post install.sh. Once that is executed, the Zen product will be installed. But let's go ahead and also handle externalizing and saving data that could be generated on a container. So let's create a folder, a directory to store data. We're just gonna create it under data. Let us make sure that the service can access it. The service runs under the Zen service account. So we're gonna run a change owner on it to Zen service and Zen data. And we also want to make sure that the appropriate permissions are set with a chmod to data. And we can tell Docker that this should be mounted as a volume. And there we go. So mount will be created for it. Next, we need something that will start up the service and keep the container up. So we'll end up writing a script for this, but let's go ahead and set up the copying of said script. So we'll make sure that it is under the right account and group. We'll call it Zen Start, and we'll just put it in the home directory of the Zen service account. And we'll want to make sure that it has execute permissions. So we will add execute to it. We called it Sendstartsh. Okay. And then to wrap this up, we will switch the user to that service user, and the command that will launch everything will be home Zen service and Sendstartsh. Okay, that's good. Now let's create that Sendstartsh script. In it, we will be using bash. Let's see. Let's first source the environment variables for the profile of the Zen service, just in case it's not loaded. Then we will start the engine. So this is the Zen engine. It's mkded microkernel. It's a microkernel architecture. And then I'm going to keep it up, and just to be quick, I'm just going to tail the dev null, and that should just keep the VM busy. However, the container busy. However, this, as you can tell, it is not handling a few things. It's not handling logging, and it's not handling graceful shutdowns, as the container stop messages will not be sent to the service. But that's okay for now. So let's go ahead and build this. Or build, we'll tag it as temp Zen, and I'll tell you why we're calling it temp for now. As I mentioned, it's missing two key aspects, which are no logging and graceful shutdowns. But I'm just showing you this so that you can grab any one of our installs from any platform, and you can quickly build a container using it and experiment yourself. However, if you want something that we have developed, as I said, Zen is certified to run on Intel Smart Edge. And we have a container out there that you can just grab and use. It's for Linux x86 only right now, x86-64. So this is why I was wanting to show you this and how to use it. Okay, so now we've created an image. So we should have a new image here. And it's called temp Zen. Okay. Next, let us create a container for it. So before I do that, as I said, we exposed the volume that we'd want to mount for data. So let's go ahead and create a volume that we'll be able to use. Volume create, we'll call it Zen temp Zen data. Okay, so now we do sudo docker create. We're going to name this container new Zen, and let's go ahead and map the volume temp Zen data to the data folder. And let's go ahead and also open up the ports and map them to the host ports, 1583, so I can access Zen from a client I have on my desktop. Okay, let's see. Anything else we need to do? No, we just need to tell it what the image base is, and it's going to be temp Zen. Excellent. So now let's just start it. called it new Zen, I believe we did. Excellent. Let's see if it's running. There it is, it's running. So let's get the host address real quick so I can connect to it from my client. I know these hosts start with 10 dots, so here we go. So let's grab this address. Let me bring up, this is the Zen Control Center. It's one of our utilities that we provide for managing an installation of a Zen server. Under here on engines, I'm going to add a new engine. And note this engine is across the country from me, so you will see some delays. And I guess that makes sense with what we're talking about next as to why you'd want to bring data processing closer to the edge of where your applications are running. So let's go ahead. See, I connected to it. It is up and running. And there we go. I can access, I have a full-fledged running container that I connected to remotely, and I can query it and fetch data. This is a sample database that we have already installed. And it comes by default with our installs, and it is accessible. So what else can you do with a container like this? Let's go ahead and hop into the container. So we can do that with the exec command interactively, new Zen, and we just run bash. Here you'll see we have a slew of utilities that we already that we install with our engine. User local Actian Zen bin. You'll see we have lots of tools. One of them being iSQL, and I can connect to that same demo database and query. Another thing I can do is create a new database, and let's do that to see the volume being used. So we have the DB maintenance utility. It'll list all the databases that are installed. Let us add a new database. Let me figure out the syntax real quick. DB maint. Let's add the name. We'll call demo. Well, let's call it something a little bit container demo. Well, container. Good enough name. Actually, I don't think there's a space between it, so it'll just be like here, container. And I need to specify where the path is going to be. So we know that we're going to put it in data, and we'll just call it container. And let's see if that works. It added it. Excellent. And the next thing we want to do to be able to access it and create some tables is DSN add. And let us do DSN add. DSN will be container. The host is localhost, and the DB equals container. We've created it. So now if I connect to the container database, I'm connected. I can create a table real quick. We'll call it temperature. And we will have an identity field. Entity. Let's add a timestamp. And let's also add the temperature. So temperature. There we go. And let's insert at least a single record. Insert into temperature. Auto IDs are automatic, so I just give it a 0 and it will come up with a unique identity. I'll use the scalar function now to get current time, and we'll just do 98 degrees Fahrenheit here. And let's insert into temperature. temperature. Oh, values, sorry. Insert into temperature values 0, now, and 98. There we go. Should have chose a shorter table name. There we go. We have one record in it. The reason I did that is to show you this. So if we go to data, we will have a folder called container. In it are files, and one of them being called temperature, which is our data file, and the rest are schema files. So what's so special about that? Well, as you recall, we created a Docker volume. Let's inspect it. So we could get the path on this local host, that's the mount point. And if I recursively just look through it real quick, whoop, what did I do? Oh, I didn't grab it. There we go. You'll see there it is. Temperature is accessible to, in this case, this host. So once the container is destroyed, your data can be preserved. This is something similar you can do, obviously, with Kubernetes and Docker here. Okay, so as I mentioned, we already have a container pre-built for Linux that does more than just this. It has graceful shutting down. So if I do, I'll let you note this: sudo docker stop new Zen. You'll notice that this will take at a minimum 10 seconds, which is the default timeout for Docker, is because it's not handling graceful shutdowns. However, if we, let me bring up my browser, and if we go to our GitHub repository for the containers that we've created for Intel Smart Edge, we can download these containers to our environment and use them. And I'll show you the difference here real quick. So how to do that, we will do a wget on copy link. We'll get this one, and it's optimized. We shrunk its size, and we did all these things to make it more accessible to edge applications. Let us also grab a Zen sample here, which is a very simple ODBC sample that just connects to the database and lets you query it. We got the link. Now we'll get the sample. Sample's a little larger. The majority of that container is actually in the Python environment that we're using, PyODBC, to connect to Zen. So let's see. So to load those up, so we'll do sudo docker load, and we'll load Actian Zen. And the same for the Zen sample. So now if we look at our images, you'll see we have two new images, Actian Zen, which is only 228 megabytes, and then the sample, which is, like I said, it's 507. The client installs only all of 13 megabytes, so the additional space is really taken up by the environment for developing in Python in this container. So let's deploy these. However, deploying these will do something slightly different. We'll use Docker Compose to stitch them together, as we need the Zen sample to know which database it needs to talk to. So let me copy over a staged file for Docker Compose. And let me walk you through what's in it. So we're creating a network called Actian. we're creating 2 volumes, one for logs, which is for the Zen logs, debug and info message logs, and Zen data, which is where it's this very similar to what we just created in the container we just created. And then for the services, we're creating one called ZenDB, which will be its actual host name. We're exposing both ports. This time, we're just going to expose them. We're not going to map them out to where they can be publicly accessible. We'll just be accessible to items in that network. In this environment, this is the one we deployed. We're accepting the EULA. Otherwise, this container will not run. And we're mounting the volumes, logs to logs, and data to data. And network is Actian. And then for the app, we're opening up port and making it public, which is 5000. We're setting up the Zen server name, which is something the app expects, ZenDB, which is similar to this name up here. And then the database that we're going to automatically connect to is demo data. So let's go ahead and deploy this. Compose up, and we'll do it detached. And they're up. So if I do a PS, you'll see we have 2 containers running. One of them is the sample app. So I'm going to connect to that one with my browser. Let me grab the host address, and we open up the port. There we go. As you see, ZenDB is automatically configured for this app, and demo data being the server. And if we just take a query and run it, we have data. Everything's working as expected. But you can do more than just that. Now that you got things in containers, you can start to stitch different services to have better observability into your network. And let's just go ahead and show you how to undeploy Zen here. With Docker Compose, we just do down. And this will remove both containers, and it will remove the network. However, it will not remove your volumes. You'll see that we'll still have 2 volumes, demo logs and demo Zen data, where it was storing the Zen logs and the Zen data. And we'll actually use the Zen logs for this next demo, which if we edit the Docker Compose yet again, let's go ahead and add some external services. In this case, Grafana and Loki. So here we're adding 3 more services. Loki, which is the log aggregator that we're going to use. Promptail, which is the service that's going to shuttle the logs to Loki. It's going to shuttle Zen's logs. And then Grafana, which is going to help us just display the logs. So let's go ahead and deploy this. So we didn't have the Grafana images from Promptail and Loki, so we're just going to grab those real quick. And now it's all up and running. Everything's running. So how do we utilize this? We're going to go to the same host and just access Grafana. Fresh install. And the defaults here. I'm going to skip. And here we're going to add our new data source, which is going to be Loki. And if you recall, in our deployment, we called the Loki container Loki. So we're just going to put the URL to be Loki. Hold on one second. Yep. 31,000. 3,100, sorry. And we're good to go. So if we're going to explore this, you'll notice here, if I go to log labels and I go to file name, we'll find, oh, we have zen.log, which are the Zen logs. And I don't know if you can see this, it's very small, but here are the Zen logs from our container being shuttled over through Loki to Grafana. So that's pretty neat. You can stitch these things together very quickly. And speaking of logs, we can look at the logs of the Zen container directly here. Docker logs. This is the name of the Zen container that was deployed. And you'll see they'll pop up right here. Also, excuse me. Also, the volumes. We can look at the Zen log in the volume. We'll inspect it. And we'll just go ahead and cat the log here on the system. And to bring it all down, we just Docker compose down, and everything should go down quickly. Notice ZenDB came down before the 10-second timeout because this shut down gracefully. It actually handled the term signal. The demo app isn't set to do that. So that's the demo for the playing around with Zen on local systems. Now, however, how do we utilize Zen in a Kubernetes cluster? Well, we can do that with Helm charts. So this is a cluster. I have a controller and a node. Let's see what resources we have running here. Get nodes. Yeah, those are the two nodes, the controller, the control plane, and the node. So in order to deploy, I've already downloaded, grabbed a copy of Zen and Zen Sample on the node. We're going to use Helm charts to deploy Zen. And we need to do that by, we can just clone the repository with the Helm charts. So let me go ahead and start that. Let me copy an address. So we're gonna git clone. There we go. So we have the Actian Zen openness project. Helm charts. We have two Helm charts, one for deploying Actian Zen and one for deploying Zen Sample. The Zen Sample, let me just show you both. So with Actian Zen, the chart is just basically, this is its third iteration, just some basic information here. As far as values, here we're going to mount the data and the logs folders to using host paths. So just mount Zen data and mount Zen logs versus doing a persistent storage or persistent store claim here, but it would work either way. And if we go into the templates, I'm not sure if there's anything interesting in deployment. I'm sure there is. There's the container. We are in an environment where we're accepting a EULA and we're setting the product to enterprise. You can change this to cloud or edge, and it will deploy those variants of the product. And you'll see us mounting the volume paths here. Data and logs are going to the appropriate locations of where we've set them in the values paths.logs and paths.zen, and we're adding the name of the Actian Zen image to it to distinguish multiple pods being deployed. Now, as far as the Zen sample goes, oops, here we go. So the cool thing about this chart has a dependency on Actian Zen. So when you deploy it, it will automatically also deploy a container for the database. And I don't know if there's the DB name that we're going to go after is demo data. And for it to set to the server, the appropriate server name, there is the Zen server name is part of the template. We have a function in the Actian Zen template chart that retrieves the full name of that deployment of the Actian Zen, and it will place it here in the environment variables, so everything can get stitched up again and work. So as this has a dependency, we need to fulfill that dependency. So we'll have to do a Helm dep update, and all that does now, if we look, there's a new folder called charts, and in it has the chart for Actian Zen that it will deploy alongside the Zen sample deployment. So let's go ahead and deploy it. But before we do that, I like to create namespaces. So let's create a namespace for this deployment. Sudo kubectl create namespace, and we'll call it Actian. There we go. So Helm install will supply the namespace, and we'll supply the sample name. We'll call it Zen deploy 1 or 01. And we will deploy this chart. Oh, whoops, sorry. Sudo. And it deployed. And we have some handy little commands here that we can run to get the address of the server and the application that's running, as we have exposed it publicly. So we'll just copy these and run them. And there we go. We have the address of the Zen sample application. If we go to our browser, and we'll just go ahead and deploy here, and there we go. So it's automatically configured to Zen deploy 01 Actian Zen, and the database is demo data. And if I query something, it is going to work. There we have it. If we go back to our cluster, we can look at the state of everything. Namespace is Actian. We'll do a get all, and you'll notice we have the pods deployed. One service is the Zen sample service for the application, and the other one is Actian Zen, which is our database. And that's how you would deploy Zen using Helm. The last bit to point out is on the node we had set, if you recall, in the chart for Zen to have the data and logs paths mounted to a folder under mount. So let's see here. Yes, we have Zen. We have two folders now, data and logs. There's nothing going to be in data other than just the empty folder, since we didn't create data this time around for this demo. However, logs, there's always going to be something in the logs files. And there's the Zen deploy 01 Actian Zen logs, and there's the Zen log. There we go. So your data and your logs can persist beyond deployments. So we can to undeploy this, we'll do a Helm, uninstall. The namespace is Actian, and we called it Zen Deploy. Zen Deploy 01. It's released. So now if we look at what's running, they're terminating. As you see, they're going down. But I can redeploy it. Actually, we can just deploy a new one. We'll call this 2. And we can deploy 3. And as you'll see, we'll have multiple services now running. And they're all configured appropriately. So that's the Helm charts. There's information both here about grabbing the containers and using them in the Actian Corp Actian Zen openness repository. And if you go to Intel Smart Edge Open, you'll find information about Intel Smart Edge Open, the mech that we are certified to run on. And if you go to their Edge apps, you'll find not only our app, Actian Zen, and our Helm charts, and a plethora of documentation on how to use the charts, but also other applications that are deployed on the Intel Smart Edge platform. Okay, and that concludes the demo portion of the presentation. Let me go ahead and share the slides again. I think it's sharing. Okay, so yeah, that's our demo. For additional resources, you can visit our website. This is actian.com. You'll find all kinds of information. Actian.com/data management and Zen embedded database is where the information is specific to us, where you'll find product features, white papers, developer resources, all kinds of very cool things. We also have a documentation and tutorial space called Zen Docs, zendocs.actian.com, where you'll find lots of information. And hopefully in the near future here, information about Zen and containers. And as I showed you with the Actian Corp Zen openness GitHub repo, the pre-built containers and the Helm charts, and then also Zen in the Intel Smart Edge Open environment and how all that looks. Please stay tuned to future developments that we're going to have with containers, SDK's plan for the next release, among many other cool integrations that we're going to be deploying with our future release. That's all I had for you today. I hope you found this talk beneficial, and I just want to thank you for your time.